All right, welcome back, everyone. Today we're going to be talking about a brief review of pre-calculus concepts that we'll be using for the entirety of our Calculus 1 class. Everything that you learn in pre-calculus is assumed that you know for a calculus class. So sometimes there will be things that will come up that will be expected of you to know and understand. If you do come across something that you just don't remember from pre-calculus, then you should definitely review those concepts as they come up, or let me know so we can review them together. Well, without further ado, let's start. First thing that we're going to speak about is just what a function is. By now, you should all know what a function is, but it's always good to review basic concepts like this one that are going to be seen throughout the whole semester. So a function f is a rule that assigns to each value x in a set D a unique value denoted by f of x. This is something that by now you should know. A function assigns to each value x in its domain a unique value denoted f of x or y. The set D, as I just gave away, is the so-called domain of the function. The range is the set of all values of f of x produced as x varies over the entire domain. Whoa. Produced as x varies over the entire domain. This is very important for us to know, as we'll be referring to the domain of the function, especially the domain of the function, throughout the whole class. So this is one of the first definitions that we need to know. I will be doing a couple of examples about some problems that have to do with functions and graphs of functions and so on from your pre-calculus class. So the first problem is the following. Let's write the equation of the line containing the given point and is parallel to the given line. Express your answer in the form y equals mx plus b. And the given problem is the following. So we have the point, let's call it P, equals -7, 2, and the function given is 5x equals 7y plus 4. This is very similar to the problem that I did when I was doing my math lab overview. Alright, so please bear with me while I get my pen. It's a bit annoying to type actually. Alright, so what's the first thing that we have? We have here a given function is given in the form of 5x equals 7y plus 4. We know that the general equation of a line, notice the general equation of a line is y equals mx plus b. This is how we write linear equations, linear functions. Here, in the problem given, we do not have the problem in terms of y equals. So we first need to rewrite that problem. We first need to rewrite this equation. So we have 5x equals 7y plus 4. First thing that I will do is take away minus 7y from both sides of this equality. So I have 5x minus 7y equals, here the 7y and the 7y cancel out, and I still have the plus 4. I could just write 4 on the right side. Now what I can do is I can subtract the 5x from both sides, and I'll have negative 7y equals 4 minus 5x. Now, to isolate the variable dy, I will divide both sides by 7, by negative 7. So we divide both sides by negative 7. So we have that y equals negative 4 over 7. It doesn't matter where you write the negative, you can write on top, the bottom, or the middle of the fraction. Equals plus 5x over 7. Remember, minus divided by minus is plus. So now we have rewritten the problem in terms of y equals mx plus b. We have the general equation of a line. And we have to look for a line that is parallel to the point negative 7, comma 2. Here, just recall, the first value of the coordinate is your x value, and the second value is your y value. So you have negative 7, comma 2. We have two ways of doing this. We could use the slope-intercept form, which is y equals mx plus b. Or we could use the point-slope formula, which is y minus y1 equals m times x minus x1. You could do it as, sometimes see it as y2 minus y1 equals m times x2 minus x1. Especially when you have more than one point, it's very useful. I really like this formula, and you'll see why when we get to the equation of tangent lines. So we will be focusing on getting good at using this formula. This is good, it gets the work done, but sometimes it is just better to have your line in this form. So that's what we're going to be using for the majority of the semester. Let's recall that a parallel line will have the same slope as this line above here. And the slope of that line is 5 over 7. Oh, my screen just crashed, my whiteboard. And I should probably mention that now. Sometimes my whiteboard will crash, so just please bear with me. Alright, we are back. Sorry about that. Alright, so we have 5 over 7 as the slope. Please keep in mind the slope is just the coefficients in front of the x. A lot of students make the mistake of writing the slope as being 5 over 7x. This is a mistake. So please do not fall for that mistake. And like we said before, the point in question is negative 7, 2. So now all I have to do is substitute accordingly. So I have y2 minus y1. My y1 in this case is just my value for y, which is 2. So minus 2 equals m. Well, m is a slope 5 over 7. Then x minus x1, but x1 is negative 7, so what we have here is really plus 7. I'm probably sure you use blue for that. So what do we have here? We have, I'll just erase this 2 from here, it's not necessary. So we have y minus 2 equals, and we're going to distribute. So we're going to distribute the 5 7s multiplied by x, and then 5 7s times 7. So 5 over 7 times x, we multiply across. That's just 5x over 7, or 5 7s x's. And then 5 over 7 times 7, 7 divided by 7 is 1. and 5 over 1 is just 5, so we are just left with a plus 5. If I went too fast, let me just rewrite it. This is probably the only time that I'll do this. This is 5 over 7 times 7. So the 7s cancel out. That's basically what happened there. So we're just left with the 5. So we have y minus 2 equals 5 over 7x plus 5. Finally, we add 2 on both sides, and we have y equals 5 over 7x plus 7. And this is the solution to the problem. If you were to graph both of these lines, you will see that they are in fact parallel. And I'm actually going to show you that right now. I'm going to use GeoGebra, which is a very nice free app that you could use to check your solutions for the class. If you are taking the lab for this class, Math 155, which you should all be taking, as they are prerequisites, you'll either be learning on GeoGebra, Maple, or MathLab, or Mathematica actually. One of those 4 tools. I like Maple a lot. I also use GeoGebra a lot. Today we're going to be using GeoGebra. So the first equation that we had was it's up here somewhere. It's negative 4, or rather y equals negative 4 over 7 plus 5 plus 5 x over 7. And the second line that we just got, that we just solved, was y equals 5 over 7x plus 7. So we have y equals 5 over 7x. Oops, put the right with the denominator. 5 over 7x plus 7. So notice that these two lines are indeed parallel to one another. So notice that they extend indefinitely, they never cross each other, and they are in fact parallel. So our problem is what we call correct. Alright, so let's move on to our second problem for today. As you probably will have guessed by now, we're going to write the equation of a line that's perpendicular. So second problem is write an equation of a line containing the given point and perpendicular to the given line. We also want to express this new line in the form y equals mx plus b. Now, remember what perpendicular means. Two lines are perpendicular, so recall, two lines are perpendicular if if the product of their slopes is -1. So that's what it means to be perpendicular. To be parallel, it just means that you have the same slope, but to be perpendicular, it means that the product of their slopes is -1. So let me go back here because I just realized I never gave us the actual problem. So the point, I'm going to call it P, that we want to pass through is 8, 9. And the equation of the line is given by 4x plus y equals 8. Okay? So let's get into this. Once again, the first thing that we will do is simply write this equation in terms of y equals. This is much easier than the first one because you just have to move the 4x over and you're done. So we have 4x plus y equals 8. So we take away 4 on both sides, and we have that y equals 8 minus 4x. Once again, this is a linear line. We could see that it has a negative slope, so it goes down from left to right, and it has a y-intercept at 8. So if we were to simply graph this really quickly, it has an intercept at 8, and it goes down like this. You could even find the x-intercept if you really wanted to. So let's continue. So now that we have written it, all we have to do is again use the point slope formula to plug in the values and solve. But let's first identify what our slope is. The slope for this equation is -4. So our new slope, the slope that we're going to use to the perpendicular line, I'm going to call it NM for new slope. M is usually the variable that we use for slope, so that's why I'm using N. But N stands for new. So the new slope is going to be a number that when I multiply by this number, I get -1. And what number could that be? Well, to get a 1, to make a 4 into a 1, I have to divide by 4. And since this 4 is already negative, then when I divide this -4 by 4, I'll just get -1, which is what I want. So the new slope is going to be 1/4. If you notice, when you multiply -4 times 1/4, you get -4/4, which equals -1, which is what we want. The rule for finding the slope of a perpendicular line is the following. If M is your slope, then -1/m is the slope of the line perpendicular. Perpendicular to the line with slope M. This class is almost 70% is probably going to be spent talking about slopes. Slopes are going to be very important. In any case, this is how we find the slope of a line perpendicular to another line. Now, let's actually use the slope point formula to find out what the actual equation of the line will be. So again, the slope point formula is y minus y1 equals m times x minus x1. Here, if you recall, m we just found is just 1/4, and the point P was 8, 9. We have that from the given part. So this was given to us right here. So now we just have to plug in. Once again, 8 is x, 9 is y. So what do we have here? We have y minus 9 equals 1/4 times x minus 8. Here we can distribute the 1/4 into the binomial, and we have y minus 9 equals 1/4 x, and then plus times minus is minus. 8 divided by 4, I believe that's 2. So we have 1/4 x minus 2. And we just have to add 9 on both sides. So we add 9 on both sides. So we have y equals 1/4x plus 7. And that will be the equation of the line. Once again, we could check this. I'm going to check quickly using GeoGebra. So I had 1/4 plus 7, so I'm just going to change this. It's 1/4. And then the other line was minus 4x plus 8, I believe. And there we go. As you can see, these lines are perpendicular. If we actually zoom in, you can see that you can make a right angle here. So our problem is actually correct. Solution to our problem is correct. I should have some in here so you can see better. All right. Moving on to our third problem. So let's say if we're given a function, the graph of a function. So suppose you are given the graph of a function. Can you determine what the equation of the function is? So the particular function that we're going to be given looks like this. So we have the plane, and then we have a line crossing the plane at an angle like this. This is x, this is y, this is the origin here. This point right here where the intercept is a point 0, -2. And then we have another point somewhere here and this point right here is going to be 4, -5. So we are given 2 points on a line. And let's call this line L. We want to find out what the equation of L is, meaning what y has to equal to for us to get this nice picture. Well, we know that the function must be of the form y equals mx plus b. How do we know that? Well, this is a straight line, and every single straight line has this general form. We also know from looking at the graph where the intercept is, where the b value is, that is actually given to us is a point 0, -2. That happens to be the intercept. So we can actually fill in some information. This is y equals mx minus 2. The only piece of information that we really need to find is the slope. And if you remember from, I don't know, 8th grade algebra, what the slope formula is, slope formula m is the change in y divided by the change in x, or delta y divided by delta x. So you can write it as delta y divided by delta x. This triangle is the Greek letter delta. That's why Delta Airlines, their symbol is a triangle. It's a fun fact. The actual formula is y2 minus y1 divided by x2 minus x1. To use this formula, we need to have 2 points on the line. Do we have 2 points on the line? We actually do. We call this point 1, we call this point 2, and we have 2 points. It doesn't matter which point you pick as point 1 and point 2, so long as you're consistent. So if you pick one point to be point 1, like this one, then that means that this is going to be my x1, this is going to be my y1, and this is going to be my x2, this is going to be my y2. You cannot mix and match. You cannot say that this is x2, but then this is y1. That's not allowed. You have to be consistent throughout. Well, filling in the blanks here, y2 we said was 5, so I'm going to do 5 minus, this minus comes from the formula, and then y1 is -2, so 5 minus minus 2 divided by x2, which we said was 4 up here, and that's minus x1, and x1 happens to be 0. So we have 5 minus minus 2, minus times minus is plus, so it's 5 plus 2, divided by 4 minus 0. So we have 5 plus 2 is 7, 4 minus 0 is 4. So we have that the equation of our line, it's 7/4. So now we could just fill in the blanks. We have y equals mx minus 2. That's what we left off here. But now we have found what m is. So y equals 7/4 x minus 2. That right here is the equation of this line L up there. So that is how you could find out what the equation of a line is given the graph. You find 2 points on the line, you find the slope between them, and if for some reason the point that you're given is not the intercept, then you could also find the intercept for the line. So that is also possible. Now we're going to move into a little bit more of an advanced function. I mean, it's a function that you may not necessarily see on a college algebra class, that's for sure. You begin to see this really in a pre-calculus class. And that will be the following. It's a radical function. So we have graph the following function for our fourth block. So we have y equals square root of x plus 4. Whenever we write a square root for this class, if I'm typing, I'm going to write SQRT, that stands for square root. So we have y equals square root of x plus 4. Okay, so we have to plot this. From pre-calculus, I expect you to know what the basic square root function looks like. The basic square root function looks like this. This is something that's expected. It begins at the origin and moves to the right. It increases very slowly. So the graph of y equals x plus 4 is going to look very similar to the graph of y equals square root of x. Alright, so the plus 4 that we have here, this change of, let me call it alpha. So if you have y equals square root of x plus or minus some alpha, some number, then that's going to shift the graph of y equals square root of x either to the left or to the right, meaning that if you had a negative value here, like x minus 4 instead of x plus 4, then it will move it to the right. So it'll begin somewhere like here. And it was a plus 4, we'll move it to the left, which I kind of just gave away what the solution should be. It doesn't reflect it though, so just be careful. Some students may think that, you know, the graph will be reflected to the other side. That's not the case. Reflections, for a reflection, you need to have the sign on the outside. So now we have y equals x plus 4. If you're having difficulty and you just don't remember how to do these problems, the best thing to do is really to create a table. So I always believe in making tables. So you have x as your independent variable. Then we have the function y equals square root of x plus 4. And then we have the output y. Because at the end of the day, we're trying to get points. I usually try to also write it as a coordinate just to remind myself that we're dealing with coordinates. So the first thing that you should really try to do is find the vertex of the radical. And how do we find the vertex? Well, we want to make sure that the inside of the radical is 0. And what value makes this inside 0? Well, if I'm adding 4 to x and I want to get that to be equal to 0, then x should really be negative 4. So I'll do negative 4. So that means that y equals square root of minus 4 plus 4, which means that I get as an output 0. The square root of 0 is just 0. So my first point that I have is negative 4, 0, which is amazing because now I have where the graph begins. Kind of spoiled it for you. I told you it's going to be to the left. But now you for sure know that this is negative 4 right there. Now, all you need is 2 more points. You need 1 point bigger and 1 point smaller than this minus 4. So what's a point that's bigger than minus 4? Well, minus 3 is bigger than minus 4. So we have y equals minus 3 plus 4, the square root of that. Well, minus 3 plus 4 happens to be the square root of 1. The square root of 1 is just 1. So we have minus 3, we hit the point 1. And now what happens when we try to do a point bigger than minus 4, like minus 5? Well, if you try to do minus 5, we have y equals square root of minus 5 plus 4, which equals the square root of negative 1. Square root of negative 1 is I. So this will be the point negative 5i. But this is outside of our domain. So outside of our domain. What do I mean by this? In this class, our domain, this is very important, is the set of real numbers. We are not dealing with imaginary numbers in this class. So for our purposes, and this is going to crash probably, for our purposes, imaginary numbers don't exist in this class. So for the purposes of this class, I will not be using imaginary numbers. Just keep that in mind. But now I have enough information to actually graph this function. So what do we have here? We have, I don't need the ruler. We have the vertex begins at negative 4, 0, so there's no changing on the axis. And then we have negative 3, 1. 1 is up here. And if you wanted to, you could actually find what the y-intercept is. You just have to plug in 0 for x. If you plug 0 for x, you get the square root of 4, which is 2. What I did there, 0 plus 4, square root of 4, which is just 2. So that's going to be your y-intercept. And yes, it's not to scale, but it's going to look something like this. It's going to go through 2. We already know when it goes to 1 and negative 3. And this is the graph of that particular function. Okay? Once again, the most important thing really is to know what the parent function looks like. If you know what the parent function looks like, then you will be in good hands for this class. Because we will have to do a lot of graphing, and when it comes to graphing rational functions, it is very important that you know how the parent function behaves. Let's move to the next one. There's another example of knowing what the parent function looks like. So we want to graph the following function. So graph the following function. The function given is g of x equals 3x minus 4 raised to the second power minus 4. So that's basically the following. Let me just zoom in a little bit so you can see it 100%. So we have g of x equals 3 times x minus 4 squared minus 4. This, believe it or not, is the general equation of a parabola. You should know this from Precalculus as well. The general equation of a parabola is f of x equals a times x minus h squared plus k, where the h and the k are the vertex of the parabola. So right away we have the value of the vertex. We also have the value by which the parabola opens up with the a. So we could graph this right away if we wanted to in that way, if you remember that. Remember that this value out here tells you how much up or down you move the vertex. And this value on the inside tells you, again, left or right movement. So if you were to sketch this, not even graph it, but to sketch it, you have an idea of where the vertex is. The vertex, and again, this is the general equation of a line of a parabola, so something like x squared. X squared looks like this, and it has a vertex down here. So this is telling you that you're going to move that vertex 4 units down, and then you have a -4, which means that you're going to move this to the right 4 units. So we expect the vertex to be down here in quadrant 4. It's good to always have an idea of where you're going to end up. And, you know, you have already taken pre-calculus, so this should not be something new. It should be something that you now need to use for your advantage, because, again, it's going to be very useful later on in the semester. But, you know, if this is difficult for you to just see it like that quickly, it's, again, okay to just make a table. I will always say, when you're not sure, just make a table of values and start plugging in numbers. Again, I always put in the point in the end because it reminds me that I'm dealing with points and values. So once again, we want to find out where the vertex is. To find out where the vertex is, we want to make sure that we find out when this middle portion right here is equal to 0. Right off the bat, you could tell that if you put in 4 for x, you have 4 minus 4, and that's going to give you 0. So I'm going to do it right here. So we have g of 4. That's 3 times 4 minus 4 squared minus 4. Well, 4 minus 4 is 0. 0 squared is 0. 3 times 0 is 0. And 0 minus 4 is simply minus 4. So when you plug in 4, you get back minus 4. Now, once again, you only need 2 more points. And I always say pick a point bigger and a point smaller. So what's a bigger number than 4? 5. If you're Patrick from SpongeBob, you might think 25. Either one will work. You could pick 25, 24. You know what's funnier than 24? 26. But we could definitely use 5. So we'll say g of 5 equals 5 minus 4 squared minus 4. Now, 5 minus 4 is 1. 1 squared is 1. 3 times 1 is 3. So we get 3 minus 4. We get minus 1. So that means that our point 5 has output 1. So we get the point 51. And finally, a number smaller than 4 will be 3. So we have g of 3 equals 3 times 3 minus 4 squared minus 4. Well, 3 minus 4 is minus 1. Minus 1 squared is 1. 3 times 1 is 3. And again, 3 minus 4 is negative 1. So we have a minus 1 in here. So that means that our point is 3. Did I say minus 1? Yeah, minus 1. 3 minus 1. So I have a mistake up here. I didn't put the minus 1 here. There we go. That makes sense. Alright, cool. So now we could actually plot this. So once again, we make our quick Cartesian plane. And I'm going to go up to 5. So I have 1, 2, 3, 4, 5. Go up to 6. So 1, 2, 3, 4, 5, and 6. Again, not up to scale. And I'm going to go down to minus 5. So I have minus 1, minus 2, minus 3, minus 4, minus 5. And we have the point 4, negative 4 down here. That will be our vertex. Then we have 5, negative 1, and 3, negative 1. So we have 5, negative 1, that's somewhere up here. And then 3, negative 1 is somewhere up here. I should probably mention something that I, didn't mention in passing. The value of A determines how the parabola is going to open up. So if A is positive, then the parabola is going to open concave up. That's a word that I'll define soon, meaning smiling. If A is negative, then the parabola is going to open up concave down, frowning. In our case, we have a 3, a positive 3 in front of the parentheses. Because the a is 3 and 3 is a positive number, we know that our parabola is going to open up smiling. So it's going to look something like this. Now we don't know where it's going to cross the x-axis. We have to do a little bit more work to find that out. You could use the quadratic formula to figure that out. But we could simply estimate that it's going to open up like this. So long as you don't mark the points here, that's okay. If you do mark the points, let's say if you make a point here, then I would like you to actually find where you're crossing, because then you're saying that you're basically crossing at that point. So I want you to specify what that point is. Sometimes you will have to find that out. We'll have tools to find that out. The quadratic formula is certainly one tool that you could use for this parabola to figure out where you're crossing the x-axis at. Okay, so again, this one, you need to know the parent function. The parent function for this is a parabola, y equals x squared. Notice that you have more than one way of writing a parabola. So you see it as y equals x squared, y equals ax squared plus bx plus c, and then y equals a x minus h squared plus k. So all of these represent parabolas. So that's something that you should know. This should not be new. All right. So next problem. Next problem is a nice one. All of these problems are nice. So consider the following functions. One of them is the absolute value of x, and the other one is the absolute value of x minus 4 minus 1. And I want to graph both of these functions on the same axis, on the same plane, and then we want to say what the transformation is. So I want to describe what the transformation is. My math lab, which is mostly what I'm giving you for on how to actually input your solutions on my math lab, will ask you to do things like this. It will ask you to describe how the shift goes, and you should be able to describe it. I mean, it's not rocket science. If you were able to graph them, then you should be able to say what the shift is. Let's talk a little bit about the absolute value function. Absolute value function, when you graph it, the parent function looks like a V. It is never negative. The outputs are never negative. You put in a negative value, you get back a positive number. You put in a positive number, you get back a positive number. So you actually are never negative, at least for the parent function. For our graph that we have here, if we notice, we have a negative 1 as a value outside of the absolute value. That means that our parent function is going to drop down 1 unit to minus 1. So we will have some negative values here and here. And now we again have the situation with the negative 4 inside of the function, inside of the absolute value bars. And this again is going to switch or shift, I should say, our function 4 units to the right. So we're going to go 4 units to the right. Again, this is not too difficult to do, especially if we make a table. So, and again, if you get good at this, you will not need a table. Once you get good at this, you will see that this is going to look kind of like that. But for now, we're reviewing. You should definitely make tables. So this is y equals x minus 4 minus 1. I have y, and then I have x and y. Maybe I should make my table smaller. I'm running out of space. All right, so let's find the vertex. Clearly, we could see that the value that makes the inside here, 0 is going to be 4. Whenever we look, we say, let's find the vertex, we're trying to find out the value that makes this inside piece 0. And there goes my whiteboard. Yeah, like I said, that's probably going to happen a couple times a video. Even when I see students over Zoom, it happens. There's a glitch that the whiteboard has when I'm recording over it. But I really like this whiteboard, so I'm gonna have to go through this. I really like it because it automatically saves my work. So if I need to upload all of this work, then I could make it available to you. So that's why I like it. All right, so we have 4 minus 4 minus 1. Well, 4 minus 4 is 0. 0 minus 1 is minus 1. So we have that when we have 4, we get minus 1. Now again, pick a number bigger than 4 and a number smaller than 4. So we have 5 minus 4 minus 1. 5 minus 4 is 1. The absolute value of 1 is 1. And 1 minus 1 is 0. So we have 5, 0 on that end. And now on the other side, we have 3 minus 4 minus 1. 3 minus 4 is negative 1, but the absolute value of negative 1 is 1, and 1 minus 1 is 0. So we have again 0 on this side. So we have 3, 0 on this side. So now we have that the graph, and remember, I was asked to plot them together on the same graph. I'm going to use green for the parent function. The parent function looks like this. So that will be y equals the absolute value of x in green. And the one in blue is going to represent our new graph. So this is 0. And we have up to 5 and minus 1. So let's go 1, 2, 3, 4, 5. So this is 5, 4, 3. And let's put minus 1 down here. So we have that the vertex happens at 4, negative 1. So that will be this point down here. And then the intercepts are 5 and 3. So we have the absolute value function going like this. This actually will look much better on GeoGebra, so I'm going to put it on GeoGebra so you can see it. Just so you can see it a little bit nicer. Alright, so we have the absolute value, so y equals the absolute value of x. And funny enough, that came out in green. Definitely a coincidence. The other one was y equals the absolute value of, I believe it was x minus 4 minus 1. And there we go. So as you can see, they intercepted that particular point right there. And it's just a shift 4 units to the right and 1 unit down. So if you had to describe this on Maple, not on Maple, on MyMathLab, then you will say you have a vertical shift 1 unit down and a horizontal shift 4 units right. You could also say, 4 units right and 1 unit down. Although typically the vertical shift goes first. But if you were to tell me, you move right and then up and down, that's fine. If you were telling me that. All right, so probably one of the most important questions that we will see in this class is the difference quotient function. So the difference quotient function is a function that you saw in Precalculus for sure. It's part of the final, at least at Lehman in Math 172. So our problem is to simplify the difference quotient And the difference quotient, I'm going to try to type it out, but then I'm going to write it because it's not going to look pretty when I type it. F of x plus h minus f of x. And all of this is divided by h. So that is the difference quotient. All of that is divided by h. We're going to compute that for the following function. And that is f of x equals 5x squared minus 4x plus 4. All right, so here we're going to have a couple of function compositions. So you need to remember what a composition of a function looks like. So let me just rewrite the difference quotient so you can see it better. So that is, that'll be f of x plus h minus f of x all divided by h. And we're doing this for the function f of x equals 5x squared minus 4x plus 4. And you need to remember how to evaluate functions and what the symbol f of x means. This symbol f of x means that what it's inside of this parentheses, it's your input parameter. That is what you're putting inside of this x's that you see here. So if I have something like 1, like f of 1, then I'm going to do 5 times 1 squared minus 4 times 1 plus 4. That's simply what it means. I'm just, whenever I see an x, I'm going to put whatever is inside of the parentheses. Now, why is that important? It's important because in the difference quotient, we have an f of x plus h. So that means that whenever I see an x, I'm going to put x plus h. So let's deal with this in a second. I'm going to take it for this problem one function at a time so you will see it better. So we have f of x plus h, that's going to be equal to 5 times x plus h squared minus 4 times x plus h plus 4. I simply substituted by x plus h wherever I have an x. Now I have minus f of x. So what is minus f of x equal to? Well, I know what f of x is. F of x is just 5x squared, 4x, and 4. But the minus sign is going to switch all of the signs from my original f of x function up there. So if I had a plus 5, well, now that's a minus 5. If I had a minus 4, that's a plus 4 now. And another plus 4 is going to be a minus 4. So my actual function now is negative 5x squared plus 4x minus 4. And I divide everything by h. So now we just have to put everything together into one big line. So what do we have here? We have 5x plus h squared minus 4x plus h plus 4 minus 5x squared plus 4x minus 4, all divided by h. So now we're going to begin simplifying things. Make sure you write the parentheses. So the first thing we do by PEMDAS is the exponents. So we have x plus h squared. So what is x plus h squared? X plus h squared, and if you don't remember this, you definitely need to look it up. It's the expansion rule for a binomial. It's going to be x squared plus 2x h plus h squared. That's what x plus h squared is. Minus, well, we're going to distribute this 4 here. 4 times x and 4 times h. Well, minus 4 times x is simply minus 4x. So I have minus 4x. And minus 4 times h is minus 4h. Then I still have a plus 4. This plus 4 right here. and then minus 5x squared, I'm doing nothing with it, plus 4x, I'm not doing nothing with it either, and then minus 4. And all of this, once again, is being divided by h. Okay, so now I have 5 times this trinomial, so I'm going to distribute the 5 into the trinomial. So I have 5 times x squared, that's 5x squared. 5 times 2xh is 10xh. 5 times h squared is 5h squared. And then I just carry on everything else. Minus 4x minus 4h plus 4 minus 5x squared plus 4x minus 4. And everything is divided by h. A lot of this type of problems delve down to bookkeeping. You want to make sure that you have, done everything slowly and avoided making careless mistakes. A lot of students lose points in this type of problems because of careless mistakes. They don't pay attention to what they're doing. But that will not be you, hopefully. So now we come down to the best part of the problem. Canceling out like terms. A lot of cancellation will happen right now. So this is where you have to be careful. I have a 5x squared. That's going to cancel out with a minus 5x squared. I have a negative 4x and I have a plus 4x, so they cancel out. Now I have a plus 4 and a minus 4. They also cancel out. And what I'm left with is a bunch of things involving h. So I'm left with 10xh plus 5h squared minus 4h in the numerator. And in the denominator, I'm left with just 1h. Now, something that we can do here is factor. We could factor out an h from the numerator because every term in the numerator has an h in it. So if I factor out 1h from each term, I'm left with 10x plus 5h minus 4 times h in the numerator divided by h. And so long as h is not equal to 0, if h is equal to 0, we cannot do this. But if h is not equal to 0, then we could cancel the h's. You need to say this. If you do not say this in a problem, you will lose points. You need to say this. If h is 0, you cannot do this. Because first of all, h cannot even be in the denominator. So you cannot divide by h. Okay, but we have this cancellation and we're left with 10x plus 5h minus 4. And that will be the end of the problem. A lot of calculus is going to involve problems like this. In fact, using calculus, we will develop a tool that will allow us to actually solve for one of these variables, for the h. We'll be able to actually solve for this. But for now, you just need to know how to get to this particular step right here. This is extremely important. You need to be able to handle a problem like this. It's just a lot of bookkeeping. That's all there is. Okay? So just a couple more problems and we will be done. Alright, so let's graph the following function. We have f of x equals 3x minus 3 if x is less than or equal to 0. And we have that negative 2x plus 4. So f of x is equal to negative 2x plus 4 if x is strictly bigger than 0. So this is a piecewise defined function. So what do we have here? We have f of x equals 3x minus 3 if x is less than or equal to 0, or f of x equals negative 2x plus 4 if x is strictly bigger than 0. So if x is positive, you're going to use the second rule. If x is 0 or negative, you're going to use the first rule. And we have to graph this. Well, these type of functions are pretty nice to graph. I do them in the following way. These are linear, but if it wasn't linear, then this is definitely the thing that you should do. Just make a table. So I have x, then I have f of x equals 3x minus 3. And when I say x here, let me actually be more specific. When x is less than or equal to 0, we're going to use this rule. We're going to get an output, and we're going to get our coordinate pair. Now, let's begin with 0. If x is 0, we have f of 0 equals 3 times 0 minus 3. Well, that's just minus 3. So we have the point 0, negative 3. Since we are graphing the equation of a line, we only need 2 points. So I'll look for another point. I just need 1 point that is less than 0. Well, I could use negative 1. Negative 1 is certainly less than 0. Well, f of negative 1 equals 3 times negative 1 minus 3. 3 times minus 1 is minus 3. Minus 3 and minus 3 is going to be negative 6. So we have negative 1, negative 6. And again, because this is a line, we know that this is going to be a line because we have linear equations here, or linear expressions. We do not need more than 2 points. If this was anything other than a line, then I do recommend 3 or more points, so you could have a better picture. Now, we have to do a second table because we are working with 2 expressions. It's a piecewise defined function, so we have here 2 expressions. Now, when we make this table, it's going to be f of x equals minus 2x plus 4. If x is positive, we have y, and we have x comma y. Now, here's the thing. You need to always check the following. And I'm going to do this in red so that you understand that this is not part of my equation. This is not in the domain. I'm actually going to check for the value of 0 here. And you'll see why in a second. I'm going to actually check for this even though I'm not allowed. That's why I'm doing it in red. This is not part of the domain. This function is only for numbers bigger than 0. But I'm actually going to check for what it is when it is 0. So we have f of 0 equals 2 times 0 plus 4. 2 times 0 is 0, plus 4 is 4. So if I were to include this in the domain, then we'll have the point 0, 4. But this is again not in the domain, that's why I did it in red. Now we just need 2 points bigger than 0, strictly bigger than 0 because that's my rule. And I'm going to pick 1 and 2 because they're very easy. Well, f of 1 is 2 times 1 plus 4. 2 times 1 is 2. 2 plus 4 is 6. So I have the point 1, 6. F of 2 is going to be 2 times 2 plus 4. 2 times 2 is 4, plus 4 is 8. So we have the point 2, 8. Now we have 5 points that we could graph. We could use to graph this piecewise function. Okay, so we have the point 0, negative 3. So as we go down 3 units on the y-axis for this point. And then we have the point negative 1, negative 6. So negative 1, so 4, 5, and 6. So let's go down here, 6. So that's a point down here. This line goes down like this. Now the other line, we know what the first value is. The first value is 1, 6. However, we also found out what the value would have been at 0. And we see that at 0, we would have been at the y value of 4. So it would have been up here. This is not part of the domain, so I'm going to do an open circle. However, every point to the right of this is in the domain, because every point to the right is actually bigger than 0, so it's strictly bigger. So we do need to know where this begins. Now we have the point 1, 6, so 5 and 6. I probably should have gone bigger on this side. So that will be a point here. And I'll say 7 and 8. So for 2 we have 8, and that will be somewhere up here. And now you could just connect the points. Again, this is supposed to be a straight line, but you get it. So here we have the graph of this piecewise function. Notice that this function has a break in it. It jumps. This is going to be very important later. We travel around this line right here, and then we jump. When we get to -3, we jump all the way to 4 and continue there. But 4 is not part of the domain. So, not part of domain. This is very important that you know this. That's why we have an open circle there. It's not part of the domain. Repeat that over and over and over again. Not part of the domain. Again, you could do this for every piecewise function that there is, that you get. Okay. We only have a couple more problems to go, at least for today. Right, so let's find the equation for any horizontal asymptote for the function given. And the function that's given is the following rational function. So it is f of x equals 3x cubed plus 2x plus 4 divided by 2x cubed plus 3x minus 3. Now from precalculus you should remember 3 things. And that has to do with how to find horizontal and vertical asymptotes. So, vertical asymptotes, to start, recall, vertical asymptotes occur when there is a hole in the domain of the function. So whenever there is a hole in the domain, you will have a vertical asymptote at that hole. In particular, for a rational function, the vertical asymptotes are the x values that when plugged into the denominator or when plugged into the function, make the denominator 0. But not the numerator. So only the denominator. So that's for a vertical asymptote. Horizontal asymptote was a little bit more involved. A horizontal asymptote for our purposes, is found by using the degree and leading coefficients of the function. For a rational function, we had three possibilities. So 1, the degrees are the same. 2, the denominator has larger degree. 3, the numerator has larger degree. Again, this should not be anything new. This is, once more, is a review of precalculus. If this is something new, then that means that you really need to go back and review these concepts because they're going to be extremely useful. If the degrees are the same, then the horizontal asymptote is simply the ratio of leading coefficients. If the degree of the denominator is bigger, then the horizontal asymptote is 0. And if the numerator has larger degree, then you have what's called a slant asymptote. And those are a little bit more tricky to actually compute. For this particular function, notice that the degree of the top function, I'll call this function in the top, let's call that n of x for numerator. And let's call the bottom function d of x for denominator. The degree of n is the largest exponent. So remember, 4x, that x that's next to the 4 has degree 0 because it's not there. 2x has degree 1, we don't write the 1. And 3x cubed has degree 3. So the numerator has degree 3. Let me do it this way. Has degree 3. The denominator also has degree 3 because the highest exponent in the denominator is also a 3. The degrees of the top and the bottom are the same. So what does that mean? That means that the horizontal asymptote is the ratio of leading coefficients, meaning the horizontal asymptote is 3/2. So the horizontal asymptote, let me write this down. Let me actually type it. Since the degree of the numerator and denominator are the same, then the horizontal asymptote is the ratio of leading coefficients. In this case, 3/2. This means that the equation of the horizontal asymptote is y equals 3/2. That is a horizontal line at 3/2 or 1.5. And also, by the way, it's important to know sometimes you will not have a horizontal asymptote. So that's something that you should know. Like for example, the graph y equals x does not have a horizontal asymptote, or y equals 2x or something like that. Linear functions do not have horizontal asymptotes. All right. I will do 3 more problems and maybe 4, and that will be the end for today. This is definitely going to be the longest lecture for the class in one sitting that I'll do. But I wanted to go over all of these problems because they're all very important for the course. And again, this is simply a review of all of the problems that, or all the most important concepts that you will need for this class. So one runs out of gas in a city. He walks 30 yards west and then 16 yards south, looking for a gas station. He wasn't looking too far because 30 yards is not much, but you know, looking for a gas station. Now the question is, how far is he from his starting point? Okay, so we have that one walks 30 yards west, not west. Okay, so if we know our system of coordinates, we have, I don't even have to do it like that with the arrows. We have north, east, south, and west, right? So he began, let's say, at some point here. We know that he walked 30 yards west. So he went this way, 30 yards. And then he went 16 yards south. The question is, how far is he from his starting point? His starting point is all the way up here. So the question is, how far is he now where he ended from his beginning point? So this boils down to a simple problem of the Pythagorean theorem. Because by walking in this way, in this manner, and comparing to the point that you began, you actually have a right triangle. Okay, so if you don't remember, the Pythagorean theorem says that in a right triangle, the sum of the square of the two legs equals the square of the hypotenuse. So that translates to c squared equals a squared plus b squared. Well, here we know what the value of the legs are. We are only missing the value of the hypotenuse c. The hypotenuse is always the side opposite of the 90-degree angle. So in that case, that will be c. So we have that c squared equals 16 squared plus 30 squared. All right, so now we have c squared equals 16 squared. Erasing. So we have 16 squared, which will be what? 256? Yeah, I think it's 256. And 30 squared should be 900. So we have c squared equals 256 plus 900, and that should give you 1156. And finally, we just have to take the square root of both sides. So we have c equals square root of 1156. If you have a calculator, you could actually, get the correct solution. If you don't have a calculator, then you could leave it like that. I believe the correct solution should be 34. That should be the end of this problem. It's just a simple application of the Pythagorean theorem. Why is this thing lagging so much? Okay. So let's do another problem. Okay, so we want to determine the amplitude. This is getting into some of the trigonometric problems that you need to know. So we want to determine the amplitude of the function y equals -5 cosine of x. All right, so if you're given a trigonometric function like y equals sine of x or y equals cosine of x, you need to know a few things. Number one is what the amplitude and the period are. So the general form of these two functions is a sine, let's call it bx, and a cosine of bx. Here a is the amplitude, b is the period. Here we're asked to find the amplitude of the function. So since we're dealing with cosine, we see that the amplitude is -5. So here we could clearly see that the amplitude is -5. Now, something that you need to definitely know is what the basic parent function for sine and cosine are. So what do the parent function looks like? For sine of x, the parent function looks like this. It begins at 0, goes up to 1, and down to -1. That is the amplitude, is 1. So you go up to 1 and down to -1. If the amplitude is 5, then you go up to 5 and down to -5. A full period for the sine wave is 2 pi. So you go up, down, and back up. And this is not to scale. Let me try to do that a little bit better. Hopefully it doesn't crash. We have up, down, and up. That looks just the same. Here in the middle, this is supposed to be the middle, it's pi. Here we have 3 pi over 2. And this point is at -1. And here we have pi over 2. This is your reference sine wave. So if somebody tells you, somebody asks you, hey, what is sine of pi over 2? You can immediately tell them that that equals 1. Without having to use a calculator. Somebody tells you what is sine of 2 pi, you could tell them that it's equal to 0. Similarly, if somebody asks you what is sine of 4 pi, because the wave repeats, you could also tell them that that is also equal to 0, and so on. So this is the basic sine wave. You can also use this wave to find out other values, other intermediate values of sine, not just these more basic ones. Similarly, for cosine, the basic cosine wave looks like this. Again, it has amplitude of 1, so it goes up to 1 and down to -1. Full period is 2 pi. But this begins at 1, goes down to -1, and then back up to 1 when it reaches 2 pi. Here at this point we have 3 pi over 2. Right in the middle we have pi, and then right here we have pi over 2. So now if somebody asked you in the train, hey, what is the value of cosine of 3 pi over 2? Then without using a calculator, you could clearly tell that person that that's going to be equal to 0. So these are extremely useful. We're going to use them all semester long, and you for sure need to know it. Finally, the last thing that I will mention are the law of cosine and the law of sines. We use the law of cosine and the law of sines to find the measurement of angles and sides of triangles that are not right triangles. So the law of cosine is the following. Okay, so let's try that again. So the law of cosine So it's the following. If you have a oblique triangle, then c squared equals a squared plus b squared minus 2ab cosine of capital C. It's supposed to be a capital C. So if you have a triangle that looks kind of like this, it's not a right triangle with sides A, B, C, and this is angle capital B, this is angle capital C, and angle capital A, then if you were to look at this triangle and you wanted to find the measurement of another side given two sides and an angle, if you remember from high school, you have side, side, angle, side, angle, side, angle, then you will use the law of cosines to actually solve this. And then you also have the law of sines, which helps you find angle measurements inside of a triangle. Yeah, my computer is like ready to give up today. Okay, so the law of sines we have the following. For the law of sine we have I'm blanking out. Yeah, we have side A over sine A equals B over sine B equals C over sine C. If you're given a triangle, again, not a right triangle, then you had side A, B, and C. This is angle A, angle C, angle capital B. Then if, let's say if you're given, I don't know, let's say you're given C equals 5, B equals 7, and capital B equals 57, then using this information you could actually find out what the measurement of angle capital C equals. Because now you have enough information to say, well, we have 7 over sine of 7 equals 5 over sine of C, capital C, and then you could cross multiply here. So you could do 5 sine 7 equals 7 sine C, then divide both sides by 7, well, 57, not 7, 57. Divide both sides by 7, and now you have 5 sine of 57 over 7 equals sine of C. Now all you have to do is find the arc sine, meaning the opposite of sine, the opposite operation of sine. So you do sine inverse sine of C on both sides. So sine inverse 5 sine 57 over 7. And this will give you actually a number, and that number will be the measurement of angle C inside of that triangle. So this is the law of sines. You could use it in conjunction with the law of cosine to find all of the sides and interior angles of a triangle. And we do not use the law of cosines, particularly with right triangles. I believe that will be it for today. This is definitely a long video. I will try for the lecture videos to not be this long, but this was definitely a long video, a long review. But this again was for the whole first week of classes, so this basically covers 2 full classes. Thank you for your attention and your time.